you guys yesterday? Last day of notes. Today. This is it. So, a little bit of a reason to get a little excited. Not meaning we're not going to be learning or reviewing or anything, but this will be the last day we actually do notes. So, one of the things that I talked about yesterday whenever we were talking about radical equations is I said you have to check your answers. It's not an option. Remember me telling you that? And you checked all your answers yesterday, and they all should have worked out if you did them right. But I told you I would talk about it today, that why we need to check our answers, why it would even be an issue today. So what we're going to learn today is that sometimes something can happen that is called an extraneous solution. So here's what happens. Let's say we start with this equation. It is an equation. It's already solved. But regardless, it's an equation. X equals 3. And what we're going to do is we're going to follow all of the rules of math. And we're going to do some things with this equation. And I'm going to show you what I mean by you get this extra solution. So keep in mind, this is my answer. X equals 3. X is 3. That's it. That's all X can be. Right? This isn't like X is 3 and 15. Right? It's just X equals 3. Agreed? Okay. So, what we're going to do first, we're going to square both sides of the equation. Am I allowed to do that? I hope so, because we did that yesterday, right? So if I square both sides of the equation, we would get x squared equals 9. Okay, well now, what if, it seems silly, but let's go back the other direction. So if I'm solving for x and I get x squared equals 9, how do we get rid of a squared? You square root it. Now here's the thing, remember from last chapter, in a way I get x equals 3, but it's not just 3. Yeah, remember that plus or minus thing? Because remember, 3 squared is 9, but so is negative 3 squared. Here's the thing. I squared both sides. You guys told me I was allowed to do that, and I agreed. We square rooted both sides because I'm solving for x. So I went from this original understanding that x is 3, and x is just 3 and only 3. And I did things following all the rules of math. And when I solved it, I got 2 answers. 3 and negative 3. But the problem is, negative 3 was not part of the original deal. Did I do something wrong? What happens here, when you do this step and you square both sides, okay, when you square both sides, it has the possibility of creating an extra answer that may not actually be a solution, called an extraneous solution. That, yes, it's a solution, it works, but, I did everything right, but if you plug it back into the original problem, it will not work. And the only way you're going to know is by plugging it in. So, to show you again, let's work out this one right here, okay? Now, it's going to be the same idea as yesterday. If I have this equation, x equals the square root of x plus 20. Same idea as yesterday. What we said yesterday is we wanted to make sure the radical, that square root is isolated. That's the only thing on that side of the equal sign. Now, this looks a little bit different than yesterday, but that's true. That square root is the only thing on that side of the equal sign. So just like yesterday, I can't take anything out from underneath the radical sign. So my only option here is to get rid of the radical sign. So just like yesterday, how do you undo or get rid of a square root? You square. And remember, what we do to one side, we have to do to the other. On the left side, when you take x squared, it just gives you x squared. On the right-hand side, just like yesterday, the square and the square root cancel each other out, and we get x plus 20. Now, my radical, my square root is gone. I just got my x's, but, see I had that x squared? This we did last chapter. Anytime you end up with an x squared, that's a quadratic equation. So remember all those methods we learned last chapter? The square root method, factoring, completing the square of the quadratic formula, you have to use one of those methods to solve this. Now, for all of the problems today, for all of the problems tomorrow, you will be able to solve them by factoring. So as a reminder, how we solve by factoring, we use the zero product property. To solve by factoring, you want to turn that into something that looks like this. You want to turn it into something times something equals 0. First problem has to be set equal to 0. So first problem, you need to move everything to the same side of the equal sign. Also remember, when we talked about this just briefly, your square term has to be positive. So typically what's going to happen is you're going to need to leave your x squared over there, and you're going to need to move these two terms towards the x squared. So since that's a positive x, we're going to subtract x. Since that's a plus 20, we're going to subtract 20. I need to do the exact same thing on the other side. Just like last chapter, this is an x squared, this is an x. You cannot, I'm going to move these down a little bit, you cannot combine those together, so it's going to stay x squared minus x minus 20 equals 0. And now remember, all of the ones today, because I'm nice like this, are going to be pretty simple and easy to factor, because all the ones today are just going to be an x squared. They can be more difficult than that, but for today, they're just going to be an x squared, which is wonderful and beautiful, because these were the easy ones to factor, because you know the only way to get x squared is x times x. And then to fill in the rest of the numbers, you know that these two numbers multiplied together need to give you negative 20. And those two numbers added together, the O and the I, add to give you negative 1. What multiplies to give you negative 20? A negative 5 and a positive 4. And then if you remember, what I have here is I have something times something equals 0. The only way I can multiply two things together and get 0, one of these has to be 0. Either x minus 5 equals 0 or x plus 4 equals 0. So add 5, we get x equals 5. Subtract 4, x equals negative 4. Here's the thing. You have to, absolutely every single time, check your answers, because these may not both be solutions. So if I plug in 5, and once again, it can be just kind of mentally, you don't have to completely show all of your work, but if I plug in 5, I'm going to get 5 equals the square root of, plugging in 5 plus 20 is 25. 5 equals square root of 25? Yes. Yeah, great, okay. Now if I plug in negative 4 equals the square root. Negative 4 plus 20, 16. Negative square root of 16. Is it negative 4? What is the square root of 16? 4! Are negative 4 and 4 the same thing? That doesn't work. Negative 4 is an extraneous solution. Negative 4 is not an actual answer. So we have to throw it out. Your only answer, the only one that works when you plug it back in, is 5. Okay, so that's what we're going to be working on today. Okay, let's get this glued into page 65, section 10.4, and this is extraneous solutions. All right, so number one, the first few look a little different than the ones that we did on the left-hand side of your notes. Number one says the square root of 5p plus 1 equals the square root of 2p plus 7. All right, so remember from yesterday, the rules from yesterday still apply. That your big goal here is to get the radical by itself. This one's a little different because you have two radicals. But, I mean, if you look at this, yes, I have two radicals, But on the left-hand side, that radical is all by itself on the left-hand side. And on the right-hand side, that radical is all by itself on the right-hand side. So it's kind of the same problem as yesterday, that I need to solve for p, but I can't subtract 1, I can't subtract 7, I can't subtract 2, because everything's underneath the radical. I can't do anything with those radicals there. So just like yesterday, I need to get rid of those square roots. So just like yesterday, if I square both sides, which we have to do anyway, it's going to get rid of both of those radical signs. And all we end up with is 5p plus 1 equals 2p plus 7. Now this equation has variables on both sides of the equal sign, so kind of taking it back to the beginning of the year, you first need to get your variables in the same place. So if I subtract 2p from both sides, 5p minus 2p is 3p plus 1 equals 7. And then we have a two-step equation. Subtract 1, 3p equals 6. Divide by 3, we should get p equals 2. Just like yesterday, and I showed you on the very first example why you have to check your answers. You need to make sure that this will work, because anytime you square both sides, you introduce the possibility, not all of the time, but you introduce the possibility of having an extraneous solution. So if I plug in 2, 5 times 2 is 10. 10 plus 1 is 11, so you get the square root of 11. We'll just leave it as the square root of 11. I just need to make sure it gives you the same thing on the other side. If I plug in 2, 2 times 2 is 4. 4 plus 7, I get the square root of 11 on both sides. Perfect. Okay, number 2. Let's say we have the square root of n plus 3 equals the square root of 11 minus n. Same as the last one, I have a square root on the left, I have a square root on the right. Both the square roots are isolated, so just like the last one, let's square both sides to get rid of those square root signs, which means I get n plus 3 on the left, 11 minus n on the right. And just like the last one, I have variables on both sides of my equal sign. So to get my variables in the same place, I'd probably add n to both sides. N plus n is 2n plus 3 equals 11. And then a two-step equation, subtract 3, so 2n equals 8. Divide by 2, we should get n equals 4. Make sure we plug it in. If I plug in 4, 4 plus 3 is 7, so I get the square root of 7. 11 minus 4 gives me 7, so I get the square root of 7. Square root of 7 on both sides. Good deal. Okay, now let's get into some factoring ones. Number 3. The square root of t squared plus 3 equals the square root of 4t. All right, so just like the last one, square root on the left, square root on the right, we can't do anything until I get rid of those square roots. So square both sides, and remember the only thing that's left is what was underneath those square root signs. In this case, which is t squared plus 3 equals 4t. Now on the last ones and the ones from yesterday, I didn't have to factor any of those. Because yesterday I never had an x squared or a t squared or an n squared or anything like that. As soon as you recognize, hey, I have a squared term, you got to solve by factoring. Okay? Which means the first problem, it needs to be set equal to 0. As soon as you see that there's a squared term, you have to set it equal to 0. Also remember what I said on the very first example. Your square term has to be positive. Most of the time it's already going to be positive for you. So leave that where it's at. Move everything from the other side towards it. In this case, it's just the 4t. So I'm going to subtract 4t. Something else to watch out for. When we are factoring, it has to be in order, which means you have to put your t squared, then your t term. So the minus 4t needs to go in the middle. And that plus 3 can go at the end. Now that it's set equal to 0, we're ready to factor it. Remember what I said on the left-hand side? These ones are going to be simple today because they're all going to be just an x squared, just a t squared. So you already know that this is going to be t times t. Then you need things that multiply to give you 3. Not many things multiply to give you 3. But add the o and I have to give you negative 4. Okay, so it's going to have to be 1 and 3, right? There's nothing else that multiplies to give you 3. A negative 1. And it has to be a negative 3. They both have to be negative. They both have to be negative. Which means either t minus 1 equals 0 or t minus 3 equals 0. Add 1, t equals 1. Add 3, t equals 3. But we need to plug these in and check and make sure they both work. So if I plug in 1, you're going to plug 1 in for the entire equation. 1 squared is 1. 1 plus 3 is 4, so you get the square root of 4, which is 2. On the right-hand side, when I plug in 1, 4 times 1 is 4, so you also get the square root of 4. So 1 works. Good deal. When I plug in 3, 3 squared is 9. 9 plus 3 is 12, so you get the square root of 12. On the right-hand side, when you plug in 3, 4 times 3, 12, square root of 12. You just need to make sure you get the same thing on both sides. Perfect. So they both work. Neither are extraneous solutions there. Okay, number 4. Well, let's say we have w equals the square root of 7w plus 18. Now this is more like that very first example we did today. I only have one radical, but it is isolated. So just like the other ones, we're ready to square both sides. So I get w squared, and then the square root's gone, so we just get 7w plus 18. Now I see that I have a w squared, which means how am I going to solve this? I have to solve it by factoring, which means it has to be set equal to 0. Also remember that your square term needs to be positive. It's already positive, so that w squared is going to stay. So you need to move both of these terms over to the other side. So we're going to subtract 7w and subtract 18. Subtract 7w, subtract 18. So w squared minus 7w minus 18. And then solve by factoring. Once again, the ones today are going to be pretty simple because it's a w squared. You know it has to be w times w. I need things that multiply to give you negative 18. Add the o and I, and give me negative 7. A negative 9, and a positive 2. Which means either w minus 9 equals 0, or w plus 2 equals 0. Add 9, w equals 9. Subtract 2, w equals negative 2. But let's plug them in and make sure it works. If I plug in 9, we get 9 equals 7 times 9 is 63. 63 plus 18 is 81. Square root of 81 equals 9. Yeah. Yep. Okay. So 9 works. If I plug in negative 2, negative 2 equals the square root. 7 times negative 2 is negative 14. Negative 14 plus 18 is 4. Square root of 4 equals negative 2. equals positive 2. Here's the thing. As soon as you see this, negative 2 equals the square root, is that ever going to happen? Never going to happen. So, what I do want to caution you about, you're not always going to throw out the negative answers, but you can throw out any answer that gives you a negative number equal to a square root. Okay, so kind of keep that in mind. All right, let's do just a couple more. Okay, let's do, what we got? 5? 5? Okay. Let's do negative n equals the square root of 4n plus 12. Okay, so just like the last ones, the square root is isolated, so we're ready to square both sides. Now, on that left-hand side, you need to square everything. What happens when I square a negative n? Yeah, it becomes a positive n squared. And then over here, I just get 4n plus 12. Super similar to the last one. We need to move everything to the same side because I have that n squared. So subtract 4n and subtract 12. So we have n squared minus 4n minus 12 equals 0. And I need to factor it. Just like the last one, we're going to have n times n. I need something that multiplies to give me negative 12. Let's do 6 and 2, but it needs to add to give me a negative 4. Which one's negative? The 6 has to be negative, right? The bigger number needs to be negative. So either n minus 6 equals 0, or n plus 2 equals 0. Add 6, we get n equals 6. Subtract 2, n equals negative 2. Now here's the thing, on the last one, we kind of saw that, okay, the negative number didn't work, because I can't have a negative number equal to a square root. But watch what happens here. When we check this and I plug in 6, you're plugging it into the original equation. And the original equation says negative n. So in this case, it's negative 6 equals the square root. See the problem? Now, 6 doesn't work because it gives me a negative number equal to a square root. Watch what happens when you plug in negative 2. Negative 2. That turns into a positive 2 equals the square root. 4 times negative 2 is negative 8. Negative 8 plus 12 is 4. That one works. So you're not always going to throw out the negative answer, but you can throw out the answer that gives you a negative number. You see the difference? Okay, I'm going to give you guys one more. I want you guys to try this one on your own. And I'll work it out kind of slowly on the board so you guys can check as you go. Okay, let's do x squared equals the square root of negative x plus 20. Oh, sorry, not x squared. I kind of saw it defeats my purpose. X equals the square root of negative x plus 20.